Hey folks, so I want to talk quickly about separable differential equations, separable differential equations, and in particular, this sort of slightly dodgy trick that we do, where we have a differential equation of the form dy by dx equals f of x over g of y. And we know that dy by dx is not a fraction, okay? It's a derivative, the derivative of y with respect to x. However, we somehow managed to split this non-fraction up, and we write, oh, this should be d of y. We write g of y dy equals f of x dx, and then we integrate both sides. Okay. Now the question is, why are we allowed to do this? Okay. And the answer is that we're essentially taking a shortcut. Okay. This does give us the right answer, but we have to understand exactly why we're allowed to do this, or indeed why we shouldn't really be allowed to do exactly this, but why it gives us the right answer. Okay. So instead of doing this, let's just take the g of y up to one side, and we have g of y dy by dx equals f of x. Okay. Nothing dodgy has happened here at all. Okay. Now, remember that what we're really trying to find is y, which is a function of x. Okay, that's what we're trying to find in a differential equation of this form. Y is some function of x. And sometimes we're going to be able to get it explicitly, and sometimes we're going to get it implicitly, but that's fine. So whenever we see a y here, we should really think that this is y as a function of x. So what we want to do is to take this and rewrite this as a total derivative. Okay, and we can do that by using the chain rule. So g of y dy by dx, that can be written just as d by dx of some g of y. Okay, where again, we really think that this is g of y of x. Okay, so that is to say that this is d by dx of g of y, which itself is a function of x, and we just use the chain rule here to end up with dg by dy, dy by dx. So you can ask the question then, what does this g need to be in order for this to make sense? And the answer is that dg by dy must be g, and we can put in the y here. Okay. And what that then means is that g is an antiderivative, big G is an antiderivative of little g. Okay. Or in other words, g of y equals the integral of g of y dy. Okay. So the fact that little g of y is the derivative of big G of y implies that big G of y is just the antiderivative, the integral of little g of y. Okay. So what we've said here is that we can take our original equation and we can write it in this form. This is just taking the g of y up to one side. We've now said, can we write that left-hand side purely as a total derivative? Okay. So what that then tells us is that we just copy all this down, then we have d by dx of g of y equals f of x. Okay. And now we can integrate both sides with respect to x. Okay, so I can do integral dg of y by dx with respect to x equals integral f of x dx. Okay, but what do I have here? I have the integral of a derivative, and we know that the integral undoes the derivative by the fundamental theorem of calculus. And so on the left-hand side, we've just got g of y equals integral f of x dx. We're not too worried about constants at the moment, because here we're going to get a constant from this side anyway, so we don't have to be too careful about that. Okay, but what is g of y? Well, we showed before that g of y was just the antiderivative of little g of y dy. Okay, and this is what we got going the quick route, the slightly sloppy route. But the point is that in order to derive this, we haven't needed to do anything sloppy, okay? All we had to do here was to say, this expression on the left, okay, can we write this as a total derivative? That is to say, d by dx of something. And we then showed that for that to be true, that something had to be the antiderivative of little g with respect to y, okay? And that just then tells us that we have this expression here, okay? And once we have this, this is precisely why sloppily we take this, we take the y up to one side, g of y dy equals f of x dx, and we integrate, okay? Although we're being sloppy in doing this, it actually gives us the same expression as if we did it the correct way, or the sort of the kosher way. Okay, very good. I'll leave it there. Let me know if you have any questions.